For the finite difference calculation for this differential equation, which represents the heat transfer between two walls of different temperature that is mediated by a rod, presumably a metal rod. So we have the boundary conditions T0 equals 40, T5 equals 200, and we have the following these formulas for the matrix. So what we're going to try to do right now is calculate, set up the matrix problem and find a solution in Matlab. So the first thing I'm going to do is define the constants. 0.1 TA equals 20. L, the length of the rod, is 10. And let's define N, in this case, is 5. H equals, or did I call it H? I called it delta X in this problem. Let's call it delta X equals L over N. And N is going to have dimension N minus 1. Okay, so we're going to start with this step size of 2. Delta X is going to be 2, so that we can compare directly to this matrix. But then we're going to write our code in general terms so that we can increase the number of steps to get better accuracy. So now I'm going to say for I equals 2 to n minus 1. So as I did before, let's see, the last step is actually not n minus 1. Or so not n, it's actually n minus 1. So we go to 2 to n minus 2, and we define things for for the first and last row outside the matrix. Remember that all of the b terms are actually going to have 0.8 in them. So actually I'm going to just add 0. Actually, sorry, that's not necessarily 0.8. What is that? H prime TA. Let's do it this way. I'm going to say C1 equals H prime times TA times delta X squared. C2 equals 2 plus H prime times delta X squared. This C2 is this one, this term, which is 2.04 for the step size of 2. These other negative ones I don't think I need to change because they won't really depend on the step size. So what I'm going to do here is I'm going to say zeros, and I'm going to then add C1. Okay, so now in this formula, so we're going to start at I equals 2 to n minus 2. So if n is 5, n minus 2 is 3. So 2 and 3. That should work. So m I comma, remember that we're interested in where the diagonal is. That is position I equals minus 1 and then C2 minus 1. We don't need to set B because it's already going to have the value we want. So in fact, that should be it for the for loop. All we have to do here on row 1 is say m I, comma, I plus 1 equals C2 and negative 1. And then here, we're going to say m of I, comma, I minus 1, comma, I equals negative 1 and C2. So we're going to need to set the B terms to, so B 1, comma 1 equals, and let's see what that would be. It's going to equal T0 plus 0.8. So have we defined T0? Now let's do that. T0 equals 40, T n equals 200. So we, over here, we need to say C1 plus T0. And over here, we need to say T or B of I, actually that should be right, comma 1 equals Tn plus C1. Okay, so let's display M and B just to see if our matrix matches. So I'm going to come over here and let's look at the Matlab command window. Okay, so let's see, B is, actually what I can do now is put this next to my notes. Come on, okay. Oops. Okay, so 2.04, negative 100, that's correct. That looks correct. That looks correct. This is wrong. So this should be a negative 1 instead of a negative 2. B looks correct, so let's take a look at the code. So we're going to look at the last row. Yes, indeed, that's wrong. Okay, so the matrix should match. Let me just run this and it should update in the command window. Okay, so now that's correct. Okay, so if we want to get a T-series out of this, let's take this off of full screen. So the T-series would be T0 M slash B transpose and then Tn. The X series is going to 0 colon delta X colon L, and we can plot X series and T series. X label would be X, Y label would be T, and let's see what we get. matrix dimensions must agree, so that's a problem. Let me see. Okay. Looks like it was a problem with the order of operations. Okay, so the temperature at x equals 0 is 40. At x equals 10, it's at 200. That looks reasonable. Now let's see if I increase n by a factor of 10, my code should actually adapt. Okay, so that does work. Let's take a look at M. It's going to be quite a large matrix, although mostly the non-zero element should be near the diagonal, and B again should be larger. So I think we have accomplished our mission. Let me take one more look at that temperature profile. Sure enough, 40 to 200. Looks like it worked.